Hello everyone, welcome to the course in operating system. Myself Rafiqul Islam, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology under JIS Group. In this lecture, our topic is round robin algorithm. And in previous lecture, we have studied about priority algorithm, and we have seen that in case of priority algorithm, there are either non-preemptive mode and preemptive mode, and criteria was priority. And in this problem, in this algorithm, we have a problem called starvation problem. And how to solve starvation problem? That is aging, which we have discussed in detail. Okay. So now in this lecture, our topic is round robin scheduling algorithm. Round robin algorithm. Actually, this algorithm is designed for time sharing system. Okay, so this is designed for time sharing systems. And what is time sharing system? We have already discussed it in our previous lectures. Okay, so round robin algorithm actually suitable for time sharing systems. And in this algorithm, a small unit of time called time quantum, or time slice. So in this algorithm, a small unit of time called time quantum or time slice is assigned to each process. Okay, so this is time quantum. This term is very important in case of round robin algorithm. And the next point, processes are executing in a circular manner. Circular manner. Okay. And here the next important point, to implement round robin algorithm, we keep the ready queue as a Fifo queue of processes. Okay, so here the ready queue is acting as a Fifo queue, first in first out queue. So ready queue actually acting here Fifo queue. And new processes are added to the tail of the ready queue, right? So suppose this is our ready queue, this is our head, this is our tail. So this is suppose process P1, P2, P3, and new process will be added in this tail part, right? So suppose this is P4, this is P4. Okay, so this is actually Fifo queue, and the short-term scheduler picks the first process from the ready queue. So short-term scheduler picks the first process, that is P1. So picks the first process, that is P1, and set a timer to interrupt after one time quantum and loaded it into CPU, right? So this is actually time quantum concept. Short-term scheduler picks the first process from Fifo queue and set a timer to interrupt after one time quantum and loaded it into CPU. So this is the important points on round robin algorithm. Okay, so designed for time sharing system. Here we have a time quantum or time slice. The execution is done in circular manner, ready queue acting as Fifo queue, and short-term scheduler picks the first process from ready queue, set a timer to interrupt in one time quantum and put it into CPU. Okay, very simple concept. Okay, now see what is the criteria of this algorithm. Criteria means in which basis we have to start the algorithm. So obviously here the criteria actually arrival time. So obviously first come first serve basis we have to choose the process from Fifo queue. Okay, and what is the mode of this algorithm? It is actually pure preemptive algorithm. Preemptive algorithm. So this is the criteria of this algorithm, and this is the mode of this algorithm. Preemptive mode. We have no non-preemptive version in this round robin scheduling algorithm. Okay, so now see some examples on round robin algorithm and clear the every point. Okay, now see the problem 1. So problem 1, this is the problem 1 on round robin algorithm. So this problem, the first problem is very simple problem. So here given process number, arrival time and burst time. So we have 3 processes, P1, P2, P3. Arrival time given 0, 1, 2. Burst time given 13, 6, 8. So this is the given data. Now using round robin scheduling algorithm, we have to calculate the turnaround time, waiting time, response time, throughput, etc. So how we can calculate these parameters using round robin algorithm? So obviously, in order to calculate these parameters, first we have to draw the Gantt chart or schedule chart. Okay, and using this chart we can calculate the every parameter. Okay, so suppose this is our schedule chart starting from 0. Okay, now here we maintaining a Fifo queue also. So in this part, it is clear that the first process which arrived in ready queue, that is P1, the next process, that is P2, and after that we have P3. So in your Fifo queue, there are 3 processes. Suppose P1, P2, P3. P1, P2, P3. This is actually head and this is actually tail. And here the assigned burst time, this is actually 13, this is 6, and this is 8. Now consider in this particular example, given time quantum, here given time quantum, suppose here given time quantum here given is equal to 5 unit. So every 5 unit we have to switch a process and assign the CPU for next process. Okay, so the first process which we have to schedule, that is P1, and obviously we have to assign P1 for 5 time units, so 0 to 5. So here the remaining time is 8. Now after that we have to schedule P2 for 5 time unit, so it will be 10, and the remaining time for P2, that is 1. Now next we have to schedule P3 for 5 time unit, so it is 15, and the remaining time for P3 is 3. So this is actually first cycle, P1, P2, P3. So first cycle completed. So again, so this is the first cycle completed. So again we have to start from here. Again we have to start from here. So again we have to assign P1 for time unit 5. So the remaining time, this will be 20, and suppose here the remaining time is 3. Now for P2, here only one time unit is remaining for P2. So obviously we have to assign P2 for one time unit. So here for P2, this is 21 and this is 0. So P2 completed and terminated. Now for P3, here we have the remaining time for P3 is 3. That's why we have to assign P3 for 3 time unit. So it will be 24 and this is 0. P3 completed and terminated. So this is called second cycle. So actually this is our first cycle. This is second cycle and this is third cycle, but in third cycle we have only one process remaining, that is P1. So the last process in our given example, that is P1, and it will be 27. Okay, so this is 0, this is 0, this is 0. So this is our scheduled chart. Okay, so I think this chart is very much clear to you, and in this manner we can maintain the Fifo queue, and there are some cycle. So that's why this algorithm sometimes called cyclic execution or circular execution. Okay, so now using this schedule chart we can calculate different parameters. This is starting time, this is finished time, this is turn around time, this is waiting time, this is response time. So starting time we can write this column using the schedule chart. Direct from schedule chart we can write the starting time as well as finished time. So for P1 the starting time is 0. For P2 it is 15, sorry, it is 5. For P3 it is 10. Actually starting time here, the first starting time. Finished time for P1 nothing but 27. For P2 it is 21. For P3 it is 24. Okay, now turnaround time. Actually turnaround time we know the formula, finished time minus arrival time. Finished time minus arrival time. So 27 minus 0. So this is the formula, finished time minus arrival time. So 27 minus 0, that is 27. 21 minus 1, that is 20. 24 minus 2, that is 22. So this is the turnaround time. Now waiting time. So in order to calculate the waiting time, and as it is a preemptive algorithm, so here it is better use turnaround time minus burst time. So here please use the formula turnaround time minus burst time. Actually, we have another formula to calculate waiting time, that is starting time minus arrival time. But my suggestion is, in case of preemptive algorithm, it is the preferable formula to calculate waiting time, that is turnaround time minus burst time. Okay, so now in this case turnaround time 27, burst time 13, so it is nothing but 14. 27 minus 13. For P2, 20 minus 6, that is also 14. In case of P3, this is 22 minus 8, this is also 14. Okay, and now calculate the response time. So response time is equal to fast response minus arrival time. So in this particular case, the fast response for P1, that is 0. There are 3 responses for P1 at 0, at 15, at 24. So fast response actually at 0. So fast response 0 minus arrival time 0. So this is 0. Now for P2, the fast response actually at 5. So 5 minus 1, that is 4. And in case of P3, the fast response at 10, so 10 minus 2, that is 8. So these are the response time for P1, P2 and P3. And now we can easily calculate the average value for turnaround time, waiting time and response time. And also here we can calculate the throughput. So throughput is equal to number of process executed by the CPU per unit time. So here total number of process executed is equal to 3 and total time taken 27. Using this chart we can say the total time 27. So throughput is equal to 3 by 27. Okay, so this is the first problem on round robin scheduling algorithm. So it is a pure preemptive algorithm. Okay, now see the another example. Now problem 2, and in problem 2 the given time quantum actually 2 unit. So here we have process P1, P2, P3, P4. There are 4 processes. Arrival time 0, 1, 2, 3. Burst time given 5, 4, 2, 3. And we have to calculate these parameters using round robin algorithm with time quantum 2 unit. Okay, now again we have to draw a Gantt chart. Okay, so suppose this is our Gantt chart, and now here we maintaining a Fifo queue. Suppose here, so this is our Fifo queue, and here there are 4 processes, P1, P2, P3, P4, right? With burst time 5, 4, 2, 3. Now starting from 0. So now when time 0, then in ready queue we have only one process, that is P1, and we have to assign P1 for time unit 2, because here time quantum is 2. Now here maintain this table also. So this is the remaining time for P1, this is 3. Now we have to assign next P2 for time unit 2, so it will be 4. So this is the remaining time 2. And next we have to assign P3, so this is 6, and P3 actually completed, terminated. Okay, so now we have to assign P4. So this is 8 and this is 1. So this is the first cycle. Now again we have to start from P1, and in second cycle we have 3 processes in ready queue, that is P1, P2 and P4. So now here we have to assign again P1 for time unit 2. So this is 10 and this is the remaining time. Now next we have to assign P2. This is 12 and this is 0. So P2 completed. And the next process which we have to assign, that is P4. Actually P3 already terminated. So here we have only one time unit, so this will be 12 plus 1, that is 13. So P4 also completed and terminated. So this is second cycle. And it is clear that in third cycle we have only one process remaining, that is P1. So again we have to assign P1 and it will be 14. So this is 0. So this is third cycle. Okay, so this is our process schedule chart or Gantt chart. In first cycle we have 4 processes, in second cycle we have 3 processes, and in third cycle we have only one process, that is P1. So now easily we can calculate these parameters. So starting time for P1 0, for P2 2, for P3 4, for P4 6. 0, 2, 4, 6. Finish time for P1, that is 14. Finish time for P2, that is 12. Finished time for P3, that is 6. Finish time for P4, that is 13. This is 6. Okay. Now, what about turnaround time? So it is finish time minus arrival time. So 14 minus 0, that is 14. 12 minus, this is 1. 12 minus 1, that is 11. 6 minus 2, that is 4. 13 minus 3, that is 10. So these are the turnaround time. And the average turnaround time will be 14 plus 11, that is 25. 25 plus 4, 29. 29 plus 10, 39. So 39 by 4. This is the average turnaround time. Now, waiting time actually turnaround time minus burst time. So for P1, 14 minus 5, that is 9. For P2, 11 minus 4, that is 7. For P3, 4 minus 2, that is 2. For P4, 10 minus 3, that is 7. And obviously, we can calculate the average waiting time, that is 9 plus 7 plus 2 plus 7. So it will be 9 plus 7, 16, 18, 25. 25 by 4. And now response time actually first response minus arrival time. So first response for P1, that is 0, so 0 minus 0, it will be 0. For P2, it is 2, 2 minus 1, 2 minus 1, that is 1. For P3, 4 minus 2, that is 2. For P4, 6 minus 3, that is 3. And average response time 6 by 4. Okay. And here the throughput should be 4 by 14. 4 by 14. Okay. So this is the round robin algorithm. So in this particular algorithm, carefully we have to draw this schedule chart, and at the same time we have to maintain this Fifo queue also. Okay. So this algorithm is suitable for time sharing system. Now, what is the advantage of this algorithm? Actually, this algorithm is suitable for time sharing system, and it is most important point that actually this is a starvation free algorithm. This is a starvation free algorithm, but it is difficult to implement actually, because context switching is very important factor here, and in this case one important disadvantage is context switching time. Okay, so for after each time quantum we have a context switch here. So context switching time is a overhead in this algorithm, but it is a good algorithm for time sharing system. Okay, so this is all about round robin algorithm. Now in next lecture we have to study multi-level queue scheduling algorithm and the last algorithm, that is multi-level feedback queue scheduling algorithm. Okay, so there are two algorithms remaining: multi-level queue scheduling algorithm and multi-level feedback queue scheduling algorithm. So thank you for watching. See you in the next one. Thank you once again.